Let's go over problem 9.28 from your textbook. It says, show how you might synthesize the following compounds from a haloalkane and a nucleophile. Let's do A. So you want to synthesize this compound using a haloalkane and a nucleophile. Well, let's take a look at the location of that nucleophile. What you will do, you will just replace this nucleophile with a halogen. It could be a chlorine, it could be a bromine. We're gonna use a bromine because bromine is a better leaving group than chlorine. And what nucleophile do you need in order to get to the product? Well, it will be CN. This happens to be a good nucleophile. So this could go through the SN2 reaction mechanism. Let's take a look at B. B, we want to synthesize this compound. Again, you have to use a haloalkane and a nucleophile. Well, this is your nucleophile, so you're just going to have the CN ion. And instead of having the nucleophile, you're just going to have a halogen. We are going to use bromine. CH2, CH2, and your Br. All right, let's take a look at C. You want to synthesize this compound. Okay, well, what nucleophile can we use? We need to have this nucleophile. Okay, we can have the anion. So that will be your nucleophile. And instead of the nucleophile, you just want to have a halogen for the starting material for your haloalkane. So just write it like you see it on the product, but instead of having this right here, you will just replace that whole thing highlighted in yellow with a halogen. Okay, let's take a look at the next one. We want to synthesize this compound. And we want to use a haloalkane. So let's count the carbons. 1, 2, 3, 4, 5. And instead, so this is a hydrogen, no nitrogen. Instead of the nucleophile, and what is a nucleophile in this case is your SH. It's like the OH group, but instead of oxygen, you're using S. All right, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And again, we are replacing the nucleophile with the halogen. And we have now the starting material, one of the reactants. So what nucleophile can we use? Well, this is your nucleophile, so SH, and just put the negative charge here. Okay, next. We have to synthesize this compound. Okay, count your carbons. Don't forget to count the carbons. 1, 2, 3, 4, 5, 6, 7, 8. You have 8 carbons. And what nucleophile? Well, this could be your nucleophile right here. This is your nucleophile. So that means that you need this terminal anion. And then again, count the carbons. Here you have 2 carbons, so A minus 2 is 6. One, 2, 3, 4, 5, and 6. And that will be your answer. Right, let's take a look at the next one. we need to synthesize this ether. Again, using a haloalkane and the nucleophile. Well, what nucleophile is it? Well, this is your nucleophile here. So you can just put out. And this part is coming from your haloalkane. How many carbons? 1 and 2. So 1, 2. Okay. Next, the last one for this problem. We need to synthesize the following compound. Okay. Keep in mind that you need to have a haloalkane at the nucleophile. Identify what is the nucleophile, this one. So if we want to use a good nucleophile, this is a good nucleophile, so we want to go to the SN2, and because we see the stereochemistry here, keep in mind for SN2 we have the inversion of configuration.